Assalamu alaikum friends. As in the previous section, we will study about the derivatives, the first derivative and the nature of their curve. So let us first revise about the first derivative. So the relation of the function with respect to derivatives gives us the following important properties. The first derivative properties. First, our function is y is equal to f and x is a function of x. So the first derivative will be written as f prime x equal to dy upon dx. So if fx, so first property is if f dash x is equal to dy upon dx, which is greater than 0. So what it means? The first derivative is positive. So this is positive. So the value of the function, it means the value of the function tends to increase, or the curve rises. So with this derivative, if the first derivative is greater than 0, we come to know that the first derivative is positive. So it means the value function tends to increase, and the curve our curve will rise. And the second property will be if f prime x is equal to dy dx is less than 0, so it means the function is negative. The derivative is negative, and the value of the function tends to decrease, or the curve falls. So these properties we come to know, and in this the curve rises from left to right, and here too the curve falls from left to right. And the third property is if the nature of the curve is neither greater than 0 nor less than 0, what exactly it will be? So if it is equal to 0 means neither less than nor greater than, at any point it means the rate of change in y with respect to small change in x at that particular point is 0. So there is no change. The change of rate of change in y with respect to x will be 0. So we have these three properties in the first derivative, and in the previous section also we have solved some questions as well. So watch out the previous video if you want to know the detail of the function and the derivatives. In the first function, we can say if the derivative is positive, so the slope will also be positive, because the curve rises, so slope will be positive. in the second property, if the function is less than 0, the derivative is negative, it means the value of the function tend to decrease and the curve falls, so the slope will be, curve is falling, the slope will be negative. So we can say that the first derivative will tell about the curve whether it falls or rises, means the slope of the curve. It tells about the slope. Of the curve, but it didn't tell about the rate of change. But it didn't tell about the curvature, means whether it is convex or it is concave, or the rate of change. So for that we need to study about the second derivative. And the nature of the curve. Now let's begin the second derivative. So here we have seen that the first order derivative has which is a function y is equal to function of x. So this gives us the rate of change in y with respect to x, while in the same manner the second order derivative, that same function, this tells about the derivative gives the rate of derivation of rate of change in y when x changes. So this triangle changes when x changes, so it tells about the rate of change and the rate of change. And so the two important conclusions we can draw, or we can say two important properties in relation to second order derivative. First is, if the function double prime x is equal to d square y upon dx square is less than 0. So when it is less than 0, it means what? It means the rate of change of the rate of change is negative. Rate of change is negative, so it means that the slope of the curve tends to decrease. And because the change in the slope, why it decrease? Because change in slope of the curve is negative. The second order derivative is rate of change of slope, not of change of rate of change. So the second case is if second derivative fx f double prime x is equal to d square y upon dx square is greater than 0, it means what? It means rate of change we are doing the second derivative, so we are repeating the rate, means rate of change of the function is positive. Rate of change of the function is positive or it is increasing. It shows that the slope of the curve tends to increase. When the rate of change is positive, the slope will be positive. Slope is increasing. So we can conclude that the first derivative refers to the absolute value of the function, and the second derivative refers to the change in that absolute value or simply the slope of the curve. The second order derivative may play a deciding role in determining the value of the curve. So it decides f double prime x decides the second order derivative. It means this role in determining the value of the curve. We can know the value of the curve through this. So there are some combinations. We have 4 different combinations of these derivative properties and the nature of the curve. We will show you graphically. So first function is the first case 1. This is the first combination. If the first derivative means dy upon dx is greater than 0, and the second derivative, that is d square y upon dx square, is greater than 0, so this combination of the first and the second derivative, both, what it suggests, and we know, as we know, the function is y is fx. This is the function we take. So it means the value of the function is increasing at an increasing rate. In the we come to know the rate of increase or decrease, at what speed it is increasing. So with these combinations we come to know that the function is increasing at an increasing rate, or slope of the curve at this point is positive. Slope of the curve is positive and increasing also, and increasing at the increasing rate as the value of x increases. So let us show graphically. This is the graph. This is our x-axis, this is y-axis, and this is the function. So if we can draw the tangent like this. This is a function. In this case, the curve is slope is concave upwards and steeper or concave downwards. It is simply convex, we can say. So f prime x is greater than 0 and f double prime x, that is the second derivative, is also greater than 0. The curve is increasing at the very increasing rate, this point, and the slope is positive as increasing as the value of the x increases. So now let us see the second curve. So this is concave upwards and convex downwards, or it is simply convex. Now the second combination, that is case 2. In case 2, the combination of the first and the second derivative, if first derivative, that is dy upon dx, is greater than 0 and the second derivative d square y upon dx square is less than 0. So it means what? This case represents the value. It represents the value of the function is increasing. This is increasing at decreasing rate, or the slope of the curve is positive, but it is decreasing. Slope is decreasing as the value of x increases. This is increases. So graphically we see this x and this is y. This is our function like this. This is tangent. Our function is this. So we see here the first derivative is greater than 0 and the second derivative is less than 0. This tells about the value, and both these functions tells about the value and the slope of the curve, and the rate of change means it is convex or concave. So this curve is concave downwards. This is concave downwards and convex upwards, or simply convex. So with this combination we come to know the slope, rate of change. It means this is increasing but at a decreasing rate as the x increases. Now the third combination, case 3. So case 3, let us see. If first derivative means dy upon dx is less than 0 and the second derivative d square y upon dx square is greater than 0, it means this combination of the first and the second order derivative represents that the function is, any guesses? Function is decreasing at an increasing rate. That is increasing rate because the first derivative is negative and the second is positive. Or the slope of the curve must be negative. Is negative but increasing as the value of x increases. So let us see graphically. This is y, this is x. How it will be? It will be like this, and we can draw the tangent. Just tangent touch this point. This is the function y is equal to fx. So this function is decreasing. It is negative slope at an increasing rate, and the slope is negative. So this negative slope tends to become less steep as the x increases, and the concave upwards and convex downwards. It is concave upwards, concave upwards, or we can say convex downwards. So this is the function where our first derivative x is greater than 0 and second derivative is less than 0 and second derivative is greater than 0. In the fourth combination, which is the last combination, that is the case 4. So the fourth combination is if the first derivative dy upon dx is less than 0 and d square y upon dx square, the second derivative, is also less than 0. In this case, the values of the second and the first order derivative, this combination of the first and the second derivative, it states that the value, it represents the value of function is decreasing at a decreasing rate, or the slope of the curve must be negative. And the slope is negative and it is decreasing as x increases. So graphically this will be like this. It is concave downwards and convex upwards. This is our function. So its first derivative is less than 0 and second derivative is also less than 0. So this curve is negative x and y. So this curve is concave downwards and convex upwards.